In this video, we're going to look at the molecular theory of matter and some of the definitions and concepts that we need to understand. First, we're going to start with solids. And so the characteristics of solids are that the particles are close together. The particles don't really move around much. You can see in this animation here, they're vibrating, but they're not moving around. And solids have a fixed shape, so the shape doesn't change unless there's a force, and they have a fixed volume. Next, we have liquids, and as you can see, the liquids are moving around here. They're still quite close together, but they can move around a bit more. So we want to say the particles are still close together, but we have flow, so the particles can change position. And the thing about a liquid is the shape is not fixed. It will fall to the bottom of the container. It will take the shape of the container, but the volume does remain fixed. So the volume doesn't change for a liquid. Last, we have gases, and as you can see, the gases are quite far apart, and they're moving around, and they're moving around quite quickly. And so for gases, particles are far apart, the particles move freely, and there's no fixed shape, and there's also no fixed volume. So a gas will fill the volume of a container that it's in. One thing we need to understand is what happens when we change from one phase to the other. And so when we're going from the solid to liquid phase, the vocab we use, the terminology we say, that substance is melting, or sometimes we could say liquefying. Most commonly, it's going to be called melting. So water has a melting point of 0 degrees Celsius. This is a really common one. Most people need to know this value. Another one you probably experienced is chocolate. Chocolate has a melting point of 35 degrees Celsius, which is kind of close to the body temperature of a human, so that's why chocolate melts when you're holding it. And gold and metals and other metals, they tend to have higher melting points. Gold in particular is 1,064 degrees Celsius. So that's the temperature you need to get gold if you want to melt it down to a liquid. Next, we're going to look at changing from liquid to solid. And so in this animation here, you can see the water that's part of this bubble is freezing in this time lapse. And so it's going from being liquid water to solid water, which is ice. And so when we go from liquid to solid, we tend to use the terminology freezing, or sometimes we can use the word solidifying, but most often you're going to see the word freezing. Another phase change is going from liquid to a gas. So here we can see some water, some food being boiled. And so we call that boiling or vaporizing. And just know that this is different than evaporating. Boiling occurs at a specific temperature, whereas evaporating occurs at all temperatures. And evaporation is on the surface, whereas boiling happens everywhere. You can see the bubbles coming from underneath. So water boiling point, 100 degrees Celsius, very important to know that one. Another common substance that is used to perform very interesting experiments is liquid nitrogen. Its boiling point is very low. So if you have very cold liquid nitrogen and you bring it out to room temperature, it boils very quickly and very rapidly and produces nitrogen gas very quickly. Another way is going from a gas to a liquid, and so we can see the condensation on this bottle. So this is when water vapor in the air has turned into liquid water, and so we call that condensing or sometimes liquefying as well. But it's important to say, if you're going gas to liquid, you want to say condensing just to not liquefying, because you want to indicate that you're going from gas to liquid, which is higher energy to lower energy. Last, there's one special case here. This picture here is showing you, it's called dry ice. So it's solid carbon dioxide. And so this is a special case here where boiling point not only depends on temperature, but it also depends on the pressure. And so when you have solid carbon dioxide at atmospheric pressure, so just in the normal atmosphere, what happens is you have a process called sublimation. And that's when a solid skips the liquid phase and goes directly to gas. And so this is depending on the pressure. It's possible to do this with water and other substances, but not at atmospheric pressure. So in the normal atmosphere, water will first go from ice to water, then to gas, water vapor, whereas carbon dioxide and some other substances will do it directly solid to gas. So that's the molecular theory of matter and all of the different definitions and applications of it.